This is part 9 of the series Circles, and in this part I'm going to continue with the two remaining cases of the angles outside a circle theorem. In the last part we ended with the two tangent case, and in this part we're going to start with a proof of the secant tangent case. So as usual, we have the outside angle 1, and we want to prove that angle 1 is 1/2 the big arc minus the small arc. That is arc BC minus BD. And so to start with, what we're going to do is we're going to go ahead and draw in an auxiliary segment in here, and we're going to use the exterior angle theorem and the tangent chord intersect theorem to show the relationship between this angle and these two chords. So let's go ahead and draw in our pieces, put in our given information, and get started with the plan for the proof. We've drawn in segment BD, created angle 2, 3, and 4, angle 4 being an exterior angle to this triangle. And now we're going to go ahead and show that angle 4 is 1/2 CB. That's going to be with the inscribed angle theorem. And then angle 2 is going to be 1/2 BD with the tangent chord intersect theorem. And then we're going to say that angle 4 is equal to angle 1 plus angle 2 by the exterior angle theorem and relate those together. So that's our idea. First thing, angle 4 is 1/2 BC and angle 2 is 1/2 BD. First statement, angle 4 is 1/2 BC. That's the inscribed angle theorem. Second statement, angle 2 is 1/2 BD, and that's the tangent chord intersect theorem. Now we're going to say that angle 4 is equal to angle 1 plus angle 2 by the exterior angle theorem. The reason we did this is because in our final form we have to have an equation. We have to have angle 1 on one side and some terms for arc BC and arc BD on the other. Well, here we have angle 1, we have angle 4, which can be written in terms of arc BC, and angle 2, which can be written in terms of arc BD. So that's all we really have to do here is get angle 1 by itself, and we're going to do that by subtracting angle 2 from both sides. And so just like in our last proof, we're getting close to our final form. We have to get these replaced with terms for BC and BD. So here we have measure of angle 4 equals 1/2 BC, and measure of angle 2 is 1/2 arc BD. So we're going to do that substitution next. We're going to substitute this for this in here, and this for this in here. So we've done that substitution with the substitution property of equality. Now, the only difference between this statement and this statement is that here we still have a 1/2 term distributed to each one of these two terms. So we have to pull that out, and these two are on opposite sides. So we're going to take care of that with the symmetric property of equality. So we're going to divide out the 1/2, factor it out, that's the distributive property, and then swap sides with both of these terms. And here's our final term. Measure of angle 1 equals 1/2 the measure of arc BC minus measure of arc BD. That's the distributive property that got the 1/2 separated from these two, and the symmetric property of equality swap the sides of these terms. And that's our proof. And now finally, let's go ahead and look at the proof of the two secants theorem, and you're going to see very few differences with this. So my suggestion would be, go ahead and give this an attempt as soon as you see the picture, and stop the video, and then start it back up again and compare your results with what I get. Here's the setup. We have two secants intersecting at point A outside, forming angle A. We need to prove that the measure of angle 1 is equal to 1/2 arc CD minus arc EB. So here's my suggestion. Go ahead, stop the video, and draw in an auxiliary segment someplace and put in some angle measures and write in your givens, and then restart the video and see where you come out. I drew my auxiliary segment in here for CE. You could have done it to DB, then all your results would have been slightly different because your angles would have been a little bit in different places, but it would have the same result. So here's my setup. Now, what I would recommend you do is give the proof a shot. See how you can work it out. See if you can use what we did in the past to work this proof out, and then start the video back up again and follow through with me. Now my plan, hopefully you got it right, and my plan doesn't necessarily have to be the right one or the wrong one. There are many ways to do this proof, but my plan is going to be to use the fact that angle 2 is equal to angle 3 plus angle 1, and the fact that angle 2 is equal to 1/2 CD, and angle 3 is equal to 1/2 EB. And then relate those two arcs together to angle 1 and have my final result. So hopefully that's what you came up with your plan. Let's go ahead and write the first set of statements. That's going to be angle 2 is 1/2 CD, and angle 3 is 1/2 EB. And both of those are going to be by the inscribed angle theorem because they're both inscribed angles. Now the next step is to create an equation that relates angle 1 to something that can be turned into arc CD and EB. And that something is going to be angle 2 and angle 3, because angle 2 is in terms of CD here and angle 3 is in terms of EB there. So my next step is going to be angle 2 equals 3 plus 1. And that's the exterior angle theorem. And so now what we have to do is get this angle by itself. We have to have angle 1 all by its lonesome on one side of the equal sign. And so we're going to have to subtract the measure of angle 3 from both sides. Now we need to convert our angles to arcs. So we have the conversion factors here. Measure of angle 2 is 1/2 CD, and the measure of angle 3 is 1/2 EB. So I'm going to make those substitutions here. So we've substituted the measure of angle arc CD for angle 2 in here, and the measure of angle arc EB for angle 3 in here. And now we're almost ready to finalize. Again, just like in the last piece, the only difference between this statement and this is that here we have pulled out the 1/2. So we have to pull out the 1/2 from both of these terms. That's going to be the distributive property. And we're going to swap sides, which is the symmetric property of equality. And we'll be done. And there we have our final statement. Measure of angle 1 equals 1/2 the measure of arc CD minus EB, right there. Distributive property and symmetric property of equality. So now we have three cases, and we can handle any of the three cases where we have two tangents, a secant and a tangent, or in this case, two secants. So let's go ahead and put this into practice into a couple of examples, see how this works out. In this case, we have a secant and a tangent. So here's the tangent, here's a secant. And we're looking for this outside angle here. So this is a pretty standard case. We know that the measure of angle x is going to be 1/2 dA minus AC. So let's write down what we've got. We know that the measure of angle x equals 1/2 the measure of arc AD minus the measure of arc AC. Don't have to do this yourself, but I'm just doing it to show you where everything is coming from. So x equals 1/2 AD 165 minus 65, which is 1/2 100, which is 50 degrees. So a pretty straightforward example, not too terribly difficult. Let's go ahead and look at another example, see if we can't give a little bit more challenge. In this example, we're given the exterior angle, we're looking for the measure of this arc inside here. So it's the same formula, same theorem. We know that this angle equals 1/2 the big minus the small. Let's go ahead and put down what we need. We have 17 equals 1/2 72 minus x. Now in this case, we're going to have to solve for x. At this point, the geometry is over. It's just algebra. It's up to you how you want to do it. The way I would work this is I would multiply both sides by 2 so that I don't have to do 2 operations to get rid of that 1/2. Here we have 34 equals 72 minus x. Then I can subtract 72, which gives me negative 38 equals negative x. Multiply by negative 1, 38 equals x. So x is 38 degrees. So not too big of a difference, just a little bit more algebra involved. Let's go on to one final example. So here we have an example of a secant and a tangent. Same thing applies. This angle is going to equal 1/2 the big arc minus the small arc. But you may think we have a little bit of a problem because we don't have any measure for this arc. But if you notice, the secant inscribes a semicircle. And so this RT is a diameter. It's going through the center, which means that this semicircle has a measure of 180 degrees. So that gives us an extra piece of information. If this is x and this is 180, then we know that the measure of angle RA is simply going to be 180 minus x. And that's going to be the measure of this arc. Now we can use our standard formula that 14 is 1/2 the big, which is 180 minus x, minus the small, minus x. And you need to be careful on how you write these things so that you don't mess up signs and things of that nature. But we have the same basic idea as we had in the last example. I'm going to multiply both sides by 2 to get rid of this 1/2. So we have 28 equals 180 minus x minus x is minus 2x. So we can just combine those together. Now I'm going to subtract 180 from both sides. And 28 minus 180 is negative 152. That equals 2x, negative 2x. Now if I divide by negative 2, I get 76 equals x. So this angle is 76 degrees. So that wasn't too terribly bad. It's just a question of figuring out what measures you have based on the information provided by the picture. All right, now we're going to move on to another topic. So I'll go ahead and end this video here and start the next topic in the next part. And I'll talk to you in the next video.